Hi everyone, my name is Yatinder Sehgal. I'll be your instructor for this program. So in this module, we'll be starting off with a bit of a primer. We'll be defining what cloud computing is, various cloud computing models that have evolved over a period of time, various deployment models that we could use within cloud, and that would be followed up with understanding of how AWS global infrastructure has been put in place and what are the various benefits it offers to its end users and customers. So a bit of a primer in terms of what a cloud environment is and what is cloud computing. So essentially, cloud computing is availability of IT resources on a demand basis, on a pay-as-you-go basis with respect to cost, and the services should be available over the internet. So this is the most generic definition of a cloud computing model, wherein cloud computing in general, be it a private cloud, be it AWS, Azure, or any kind of a cloud environment, wherein the services are available on demand basis, available over the network with pay-as-you-go pricing model. So this is a definition at a very high level, wherein you'll get IT resources of your choice. So the IT resources could include network, it would include servers, databases, management tools, DNS services, any IT service that you can think of. So at a broader level, this is the definition of cloud computing and what a cloud is. So essentially, it is the responsibility of the cloud provider to provide all these services to you, wherein you as a customer really sign up with the cloud provider and those services would be made available to you on a need basis. So for example, let's say you are a Flipkart or a Amazon or a eBay. So on a specific day, if the traffic was to increase exponentially. So in a traditional environment, handling these kind of situations is pretty complex, wherein you are limited by a number of IT resources that you have. It could be compute resources, storage requirements, or scaling up your database services. But within cloud environment, it is just matter of minutes doing some configurations wherein you can scale up and scale down based on need basis. So there are certain attributes that any cloud model should support. The first one is on-demand self-service, wherein, as I mentioned, the services should be available on a demand basis. So if I need 10 servers, the servers should be made available to me. So this was a typical challenge in traditional environments, wherein you are limited by IT resources that you might have. Then the services should be available over the network. So predominantly the word internet is used, but in generic terms, it could be any network. So regardless of my location, let's say I'm sitting in US right now and I want to provision a resource in Europe region. So regardless of the location where I am, I can provision resources in any geographical location of my choice. Then it should support the concept of rapid elasticity, which actually refers to, as I mentioned, you want to scale up or scale down. So a simplest example would be you need more servers on a given day. So let's say you want to expand from 100 to 200 servers. You anticipate spike in traffic. So it's just a matter of configuration. There are very variety of services should be available rather to help you scale up. And when you don't no longer need it, you can actually scale back down. So you only pay for the duration wherein you need extra resources. So that way, it's a savior in terms of the amount of money that you would have spent on the scaling up and scaling down process. Then it should be a measured and a billable service. So that's one of the fundamental aspects. So how do you bill a end user or a customer? So the service should be measurable and likewise billable. Last option is resource pooling. It should support the concept of multi-tenancy, wherein resource can be shared across multiple users or customers. Why there was a need for cloud environments. So right now I'm keeping the definitions that are applicable to be it a public cloud or be it a private cloud or a hybrid cloud. I'll be explaining these terms very shortly. So the need was very simple, wherein companies, rather than focusing on infrastructure requirements, they could actually focus on developing the applications or technology stacks that they wanted to build and serve to their end customers. Then faster service provisioning, and that's one of the very important features we'll see through the program, that how easy it is in a cloud platform to provision services and start consuming them. So Net result is that you get more efficient, more productive, and able to market your products at a much faster rate. Then you have cost effectiveness. So again, with cloud models, specifically with respect to public cloud offerings, you don't have to spend any money as a upfront cost to build that particular service. So let me take a very simple example. Let's say you want to provision a virtual server in your environment. So you'll need an underlying network for sure. You'll need power systems, backup systems, multiple internet connections coming in. Then you'll need the physical host. Then you'll need to purchase licenses for the hypervisor level. And then on top of it, you will be provisioning your virtual servers. And then you need to have some kind of a storage environment. So that calls in for a lot of cost. Whereas in the cloud model, you can escape all of this. So you only pay for the duration where you have consumed the resource. So the cost is variable based on the resource that you want to provision. But in most of the cases, you pay by an hourly basis. So for example, you want to set up a test environment for 2 days. Just go ahead and provision the environment in the cloud, trash it after 2 days. You only end up paying for those 2 days. So pricing is one of the aspects. Other aspects could be performance, security, fault tolerance. So all these aspects have to be weighed in. And last option is dynamic scaling. This refers to the elasticity property that we just discussed, that the service should be able to scale up or scale down. Since most of the services are managed by the cloud provider, so you can best be assured of that the services would be highly available and fault tolerant. So a couple of other advantages. So I've already spoken about cost. So this is point number 2, trade capital expenses, which refers to no upfront cost involved. Just you can go ahead and pay as you go model. Next advantage is go global in minutes. So with a player like AWS, which has a presence across the globe, so you could set up your technology stacks in any region of your choice, in any geographical location of your choice. Or if your business is expanding and you need to have multiple deployment regions, you can use AWS as a single player. So many organizations have their technology stacks deployed in, let's say, London, US. They have different stacks. They have tie-ups with the different service providers. So in this case, if you were to select AWS, using AWS platform, you could have your deployments in multiple regions. Then you benefit from massive economies of scale. So the cost at which AWS can procure a service versus the cost that you as an individual customer would have to pay for varies significantly. And Amazon believes in charging the customers less wherever they pay less. So this simply means that, let's say, if the cost of procurement of a service for Amazon is less in a specific geographical location, they would be charging the customers accordingly. If the cost is low, they would be charging you low. If the cost is high, they'll be charging you high. So that means your pricing would vary from one geographical location to another geographical location. So the variance is not significant, but if you're talking at scale, yes, these things would definitely come into play. And lastly, no guessing about capacities. So this is, I think, one of core features wherein in traditional environments, once if you have scoped out for various IT resources, if you were to scale up, again, you would have challenges. Whereas in the cloud environment, you can scale up based on your demand needs and then you can scale back. So this in totality sums up what are the various benefits associated with the cloud computing. So these are applicable across all the players that are rendering cloud services, be it AWS, Azure, Google. The benefit that you get with AWS is number one is the set of services that they have to offer. So they offer in excess of 100 services to the customers. They have a very wide footprint across the globe. So if you're a global organization or for that matter, even a localized organization, you can sign up for services on AWS. Over the last several years, various cloud computing models have evolved. The first one being infrastructure as a service. So in this model, essentially what you leverage is IT resources from the cloud provider. You manage them. You are responsible for your application, their maintenance, and so on. So essentially from the cloud provider, you are picking up IT resources such as network, servers, storage. You'll need to manage every aspect of it. I think we have a great slide ahead that gives you a good comparison with respect to each cloud computing platform. I just spoke about infrastructure. So network storage, servers, and virtualization, typically these are controlled by the vendor. And you as a customer, you are responsible from operating system level and above. Coming to platform as a service, the provider would give you the platform. The platform could be Java, .NET, Node.js, any environment that companies work on. And in this case, the vendor is responsible to manage till the runtime environment. And you as a customer are responsible for developing your applications and data. So good example would be Google Sites. If you want to develop a site, you really don't know what kind of infrastructure, underlying infrastructure and the underlying platform that Google is running. And then you have software as a service, wherein you are the end user of that service. So good examples of this would be, let's say, applications like Gmail, Office 365, wherein as a customer, you only care about the features and services extended by these applications. You don't care about the underlying infrastructure or what are the underlying platforms these are hosted on. So you are getting that as a service, as an end product. And lastly, you have on-prem. So on-prem is something that you control everything in totality. So this is in quite contrast to all the other three models. So on-prem, which is the traditional model, wherein if you want to have a very tight control over your environment, there are some security concerns that might not be addressed by cloud environments. So in those cases, you can build your own environments. So I've spoken about platform as a service. Then you have software as a service. We have already spoken about. So the variety of deployment models, you have public cloud platforms, so players like Google, Microsoft, Azure, even IBM has one software. So these are the public cloud platforms that are available for the end users. Then you have private cloud platforms. So this is where this refers to the private cloud model that we just saw. So you as a customer are responsible for it. Then you have hybrid. So hybrid generally refers to if you're consuming services across two platforms. So two environments rather. So one environment could be in AWS. The second environment could be a private data center that you own. So these are generally referred to as hybrid environments. And then community model, wherein several organizations come up who have a similar set of needs, they set up their own environment. So they are actually sharing the cost of that particular environment, and the services are being used by multiple organizations. Okay, so moving on, let's start with the introduction to AWS. So AWS, as we have said, is a public cloud platform extending IT resources such as compute, database storage, network, content delivery services, and it offers more than 100 services actually. And while going through each of these services, we'll also see the cost aspect of it, wherein for every resource that you use, you are charged on an hourly basis. So there was a market survey for public cloud adoption for the year. There was a comparison between 2017 and 2018. So AWS, as it stands today, controls 64% of the cloud market, and rest of the players, barring Azure, no one is even close. So I'll come back to this slide. So essentially, this is talking about various services on AWS and equivalent services that are available. So these are the most common used services, such as EC2 is your virtual servers. So in AWS, they're termed as EC2. Azure refers them to as virtual machines. Google refers to them as compute engine. So different players, different terminologies that they follow. So set of core services, they are being represented by different names in different environments. So there are various benefits. We have already spoken at a higher level what the benefits of cloud platform are. So all are applicable to AWS as well. Cost effective. We have seen it's a pretty dominant player in the cloud arena. Scalable and provides high performance. Any service that you use, if it's a compute resource, you're using network resources, you're using database resources, any application services such as email services or notification services, monitoring services, these are highly scalable and can deliver the performance. Very easy to use. As we'll see when you provision the resources, it's pretty easy to set up these services and integrate it within your applications. Services are reliable since these services are managed by AWS. So AWS takes the responsibility of managing and maintaining these services. Then with respect to security, so security again here, There are a couple of things that would fall under AWS responsibility and a couple of things that would be responsible that the customer would be responsible for. So we cannot take it for granted that AWS is responsible for total security of your technology stack. So while talking about each service, we'll go through this aspect for sure, the security aspect, because that is one of the most concerning factors while making a decision on moving to cloud. Refer to the illustration on the screen. So you have AWS global infrastructure. So this refers to Amazon's footprint across the globe. So this is essentially divided into three parts. You have regions, availability zones, and edge locations. So on top of this infrastructure, they have classified certain set of services as foundation services, such as compute, storage, database, and networks. So the idea here is that any technology stack cannot be completed without these four foundation services. So you'll need compute resources, you'll need the servers, you'll need storage for sure, you'll need a network in which you want to operate within AWS, and then any application would need a database in the backend. So these services are referred to as foundation services, and the idea here is that any application will have to use all these four foundation services. And then on top of it, again, it is customer's choice that whether they want to use any other service over and above the services that are mentioned here. So the first term that I'll be talking about in context to AWS is the term regions. So regions, essentially, they are geographical locations in which AWS has the presence. So I'll just log into the portal. Shortly, I'll demonstrate on how do you sign up for the free tier account as well. So when you sign up for the account, essentially you supply an email address and you set up a password. So that's what I'm using to sign up, or rather logging to my account. So on the top right hand corner of your browser, you would see the region in which you have logged in. So any resource that I provision would be logged in the Oregon region in this case. So as of today, Amazon is operating out of 18 regions across the globe. So regions, they are synonymous to geographical locations in which the AWS operates. So it's a separate geographical region. I'll come to availability zones in a bit. So first, let's talk about on what should be the criteria in choosing a right region. So the first aspect is service availability. So let's say you want to use foundation services are available across all the regions. So let's say you are looking out to set up a warehousing solution, and for any newly provisioned region, warehousing solution might not be available for the initial period. So in that context, as a solution architect, you need to figure out that whether the service is available in the target region of your choice. The second aspect that you would be looking at is security and compliance requirements. So let's say you're working in healthcare organization in US. So law of land states that the data needs to be sitting in US. So naturally, from a security perspective and compliance perspective, your choice would be somewhere in US. Then the third aspect is cost, which refers to, as we said, that pricing of a service, they're not similar across all the regions. So if you are talking at scale, this could also be one of the deciding factors. And then you have user location and latency. So this refers to, let's say my target audience is in, let's say, Asia. So what region should I select so that users are closest to my application? So my obvious choice would be, let's say, Singapore in this case. So combination of all these factors would help you decide which region to choose in which you want to provision your environments. So based on various factors that we spoke about with respect to selecting a region, the factors that we discussed was service availability, service and compliance requirements, cost, proximity to the end user or latency. So based on these factors, so in this case, you see an analysis has been made with respect to a specific virtual server, and the region, the North Virginia region, is the cheapest, wherein you pay about $460, and the maximum is Sao Paulo, which is $719. So this is only with respect to cost. The second term that we should be familiar with is availability zones. So availability zones are essentially the data center environments that we refer to in day-to-day basis. So essentially availability zones are data center environments that AWS has. So let's say this is a specific region R, and by design, whenever AWS comes up with a new region, by design at the bare minimum level, they'll have two availability zones. So essentially, these are two data center environments that AWS comes up with, and the services that they offer, these are extended by these availability zones. So both the availability zones, so in this case, we're talking only about two. So there are regions in which they would have as many as 6 availability zones within a same region. Also, these availability zones are connected with very high speed networks, low latency networks. So the idea here is that from a solution architect perspective, that you should have a distributed workload across two availability zones. So in the event of availability zone going down, your application would still be available from the second availability zone. So I recall a scenario a couple of years back. There was an electrical storm in North Virginia region causing an outage in one of the availability zones. So since our workloads were distributed across two availability zones, our application was not impacted. So by design, at the bare minimum, every region would have two availability zones. So this is to ensure highest level of availability for your technology stacks. And from a solution architect perspective, you need to make sure that your workloads are distributed across multiple availability zones. So for example, in the North Virginia region, if you were to take a look at number of availability zones that we have 6 availability zones. So it is up to the customer on how many availability zones that you may want to use. So this is to ensure the highest level of availability for your applications. So if you were to take a look at some another region, let's say Mumbai. So in the Mumbai region, you'll see 2 availability zones. So number of availability zones by design is 2. So they can add more availability zones, and that depends on the volume of business that they generate from that specific region. So availability zones, they are data center environments from where AWS services are rendered, and you need to design your applications in a distributed fashion across multiple availability zones to ensure highest level of availability and fault tolerance. So we'll see that how do we distribute our workloads across multiple availability zones. So by design, we have already said it will have bare minimum 2 availability zones. So you need to have distributed workloads, be it any tier of your application, web tier, application tier, database tier. So you need to have distributed workloads across by leveraging multiple availability zones. So this is a great slide that you see in terms of achieving high availability for your technology stacks. So on the left hand side, if you're a customer who is on AWS and you have selected any region for deployment of your application, so you're leveraging multiple availability zones out here. So in this case, you could achieve high availability by leveraging a single availability zone by provisioning multiple resources within the same availability zone. A good design, no single point of failure. But what happens if AZ1 was to go down? So if this was to go down, even if I have multiple resources in this availability zone, if the AZ goes down, everything is down. So a better idea is to leverage multiple zones wherein you are spreading your workloads across two availability zones. So even if one goes down, you're still good. So now if you were to move on a higher availability scale, you could choose two deployment regions. So again, you could leverage the same approach as we saw in the first region, wherein again, you are leveraging multiple AZs. This is generally used for building up of DR environments, part of BCP, business continuity planning. You could leverage multiple regions. In addition, let's say what happens if something happens to AWS for some reason, all the regions are impacted. So in that case, you could leverage two cloud platforms. So as you see in the screen, you have AWS and Azure. So you could have one deployment in AWS and the second deployment in Azure. But keep in mind on the scale, if you refer, the more you move on the higher availability side, there'll be a price impact as well. So again, you'll have to check out with your organizations what are your SLAs committed to your internal and external customers. So let's say if you're a banking organization, can you actually afford to have a downtime or some kind of a data loss? The answer is no. So you'll be looking at this scenario in totality. Else, let's say your application, your SLAs are that, okay, if there's an outage of, let's say, 10 minutes, that is okay with the customers. So accordingly, you will have to design and place your workloads accordingly. So this is an important concept. So now we know what regions are, what availability zones are, and in building up highly available environments. So for example, we'll talk about having deployments in 2 regions. So you'll need to have some kind of a data replication in place across these 2 regions. So AWS provides you default connectivity methods wherein resources from one region can communicate over second region. So I'll talk about those connectivity methods in the network section when we talk about it. But with respect to configuration of replication, it is customer's responsibility on how you want to configure replication of your data from one region to the another. So that comes under customer's responsibility, whereas providing a medium for connectivity across these 2 regions would be AWS responsibility. So again, why replications between the regions? Increase fault tolerance, increase redundancy to reduce latency. Covered that. We have spoken about availability zones. So this is a generic definition of availability, which refers to a system or a component to be operational and accessible anytime. So even if there was an outage, how do you recover from that? Either without any downtime or if any downtime is applicable, how do you recover as quickly as possible? So there are various methods to measure availability. You have terms like MTTR, which is mean time to repair. So anybody coming in from systems background would be able to relate. So these are generic terms that are used to measure availability. So MTTR refers to mean time to repair. So this is the time that you need to fix your service. MTBF is mean time between failures, which means, let's say you had a failure day before and a failure today. So what is the mean time between the failure? It is 2 days. Then you can calculate the availability based on the formula given out here. So AWS offers you highest level of availability. So in my experience, one outage that I spoke about that happened a couple of years ago, and that was with respect to one availability zone not being available. So that was due to act of God. These are the things that you can't help out. So even if it was a private environment, your own hosted environment, you would have been impacted. And there was another one brief outage on S3 couple of months back. So even that was taken care of quickly. So you can measure the availability, MTTR, MTBF based on the values that are available. To increase fault tolerance, increase higher levels of availability by design, 2 availability zones per region. And these availability zones are connected by very high speed, low latency networks. So with respect to why high availability is essential, so acts of God such as earthquake, flooding, you could have hardware outages, power outages, issues related to software, network outages, and lastly, with respect to data. So from your perspective, you'll need to figure out that where all you need to build redundancies. So as part of AWS global infrastructure, we have spoken about regions, availability zones. The third term that we need to be familiar with is edge locations. Edge locations, they are different than availability zones. So essentially, these are caching locations that are spread across the globe. And as I said, they are caching locations. So if you have a user base spread across the globe and users are trying to access your application, so in a normal case scenario, what would happen is, so let's say this is my deployment region. So let's say this is US. Within US, you have again multiple regions. So let's keep it simple at this point of time. So you have users coming in from Singapore, Australia, and let's say Europe. So you have a distributed user base. All these users might not get the same experience in terms of latency. They might see buffering issues while downloading the content. So couple of approaches to mitigate that is, number one, have multiple deployment regions. But again, that can be very expensive. Or use a service like CloudFront. So CloudFront is a content distribution service which actually uses edge locations. So these are edge locations spread across the globe. So please note, from examination perspective, edge locations are not availability zones. They're completely different than availability zones. So now if a user from Singapore was trying to access, the user would be directed to the edge location in the Singapore region. Likewise for Australia, he goes to the Australia edge location, and likewise for Europe. Edge locations, they are connected on very high speed networks across regions. So the response that you would see would be far better as compared to when the user was trying to access the application directly. So imagine companies like Netflix, Amazon Prime, who are in the business of content distribution. Can they afford to have multiple deployment regions? No. So they'll have a central site and they'll be front ended by a service like CloudFront, which in the background would use edge locations. So edge locations, essentially, they are caching locations. So the users would be served the content from the edge location directly. So since this edge location is in Singapore, the user would be served the content from the Singapore edge location. So the only exception if the request is new or fresh. So in that case, the edge location will have to actually send the request to the original, and once it gets the response, it would cache the content. So benefits of edge location. So you can cache your data from your applications to AWS edge locations. You maintain a single environment and typically used in content delivery network scenarios. And you only pay for the data transfer that actually happens. We missed out on this slide, which defined latency. So latency is the time required to transfer data from client to server. So round trip time that we are talking about, which is when the request is sent and when the response is received. So in a traditional scenario, it would be higher. Whereas if you are leveraging solution like CloudFront distribution, which leverages edge locations, the response time would be much faster. Next, we'll talk about on how do we set up AWS account on the portal. So AWS gives you 12-month free tier account, wherein most of the services that we'll be using for the program, they are covered under the free tier. So that means you don't actually have to pay a dime to use those services. So all what we need to do is we'll go to the portal, make sure you select the account as personal. There are mandatory fields like first name, second name, email address, password, and then you'll also need to supply your credit card details. So that is only for validation purposes. So you're not charged on that credit card. Even to an extent, if you have consumed a service that is not eligible under free tier, it would generate an invoice and notify you. That's about it. So they use credit card only for first time validation. So if you're signing it from India, you are charged, let's say about 2 rupees, else from outside, couple of cents just to validate that you are a legitimate user. So what all services that we are entitled to? You have Elastic Compute, which is virtual servers. So how many hours that single user is entitled to? So you are entitled for 750 hours of virtual servers on these platforms, Linux, Red Hat, and 750 of Windows. So 750 hours is the total time limit that you can use only for a specific instance type, which is T2 micro instance. So this is the instance type refers to the hardware specification, number of CPUs or memory thrown into that particular thing. Likewise for load balancers, again 750 hours. The caveat is 15 gigs of data processing. Then storage, again, what is the amount of storage that you can use? So you can use 30 gigs. And likewise for any other service that it is very clearly marked on the portal which service is eligible under free tier and which is not. So make sure if you're practicing something on AWS, provision the resources and make sure you terminate them once you are done with them. So go to the portal. You can use this link. So go to create a free account. So type in your email address, password, and if you want to give any alias name to your account, else it assigns 12-digit account number. Continue. Then specify it's a personal account and specify first name, last name, and the region place where you are signing up. So accordingly, you will be billed. Then provide your credit card information and you are good to go. I'm referring to the document right now. This is the second page. You'll need to select personal out here. Select country wherever you are, region where you are signing it from. That's about it. If you actually look at the URL, if you see, it got redirected to one of AWS storage services, which is called S3. So this PDF is actually hosted on S3 storage service. So for any service that you choose, so let's say I want to provision virtual server. So I'll explain these steps. So a specific instance type is only eligible, and it would be very clearly marked that whether it is available for the free tier or not. Likewise, any other service that we pick up, a database service or any application service or a monitoring service, very clearly indicated whether they are applicable or not. So I'll be explicitly mentioning that some of the services that we'll do, they are not eligible under the free tier account. So I'll be explicitly mentioning that to you. Also, let's say if you're exceeding your limits or you want to keep a tab on your expenses on your AWS account, AWS gives you the flexibility of creating billing alarms. So billing alarms is a way of getting notified that, so let's say you had a budget of, let's say $100. So you're about to exceed that. So you can set up a billing alert. Hope you had a good time today. Thank you. Bye-bye.